Can Boston Dynamics beat Tesla in figure? Today on AI News, I'll break down 5 new features just announced for the newest Atlas humanoid. Plus, I'll show you what it can do. But first, Atlas just got several physical intelligence upgrades that you actually can't see on camera. That's because while most AI upgrades are about what a robot looks at, Atlas's newest intelligence updates are about how it feels the weight of the physical world instead. So in this example, we're looking at how Boston Dynamics is moving past basic vision tracking and using reinforcement learning to let Atlas master the chaotic physics of a real job site by lifting a fridge with its contents shifting around inside. In fact, Atlas achieves this via reinforcement learning trained in simulation, using implicit perception derived from body proprioception, which is its internal sense of self-movement and spatial orientation. And this allows the control policy to autonomously adapt to real-time physical variables, including the exact mass and shifting center of gravity of an object, varying levels of surface grip between the robot's limbs and the load, and the specific configuration where the object settles against the robot's torso and arms, allowing the Atlas to safely bear hug and transport irregular objects weighing over 100 pounds, despite being trained primarily on 50 to 70 pound models. But this is only possible because of Atlas's massive hardware overhaul that features 5 new engineering upgrades to optimize its speed and performance. Starting with upgrade number 1, dual actuator standardization. So the robot's entire chassis now uses only 2 types of rotary actuators, which minimizes its component variety, simplifies mass manufacturing, reduces production costs, and makes the robot's physical dynamics much easier to mirror in digital environments. Then, its second upgrade is its structural symmetry. Specifically, the robot's left and right limbs are entirely identical. Plus, the shoulder-to-shoulder structures replicate its pelvis-to-pelvis design. And on top of this, symmetrical front-to-back feet also allow Atlas to move backwards and forwards with equal capability. Next, its third upgrade is its infinite joint rotation. By eliminating external cabling across joints, which was historically a primary point of hardware wear and failure, the robot's actuators can now spin indefinitely, which provides unique, hyper-efficient movement pathways that are simply impossible for humans to replicate, which could allow it to do tasks more efficiently than humans, or else tasks that no humans could do at all. And to keep everything simple, the fourth upgrade is modular component swapping, where the arms, legs, hands, and head all function as independent field replaceable units. So what it means in the real world is that technicians can swap out damaged limbs within just a few minutes, which also makes it easier for other Atlas robots to fix each other sooner. And to extend periods between repairs, its fifth upgrade is advanced thermal management. As Atlas is doing all kinds of flips and handstands, its 90-kilogram frame features built-in heat dissipation, ensuring its internal hardware systems can withstand this sustained exertion even on a hot factory floor, all without frying its components in the process. But all 5 of these physical upgrades don't just make Atlas tougher, they also solve the single biggest problem in AI robotics today, which is closing the sim-to-real gap. By combining high-precision physics modeling with domain randomization, like intentionally injecting the chaos of shifting weights and floor friction across millions of simulated hours, Atlas's AI learns to adapt to real-world unpredictability. And the final result here is a rapid pipeline where a complex behavior trained in digital simulation can be reliably deployed and validated on physical hardware, all within just a matter of days. Meanwhile, there's been a completely different AI breakthrough from RLWRLD to tackle high-precision dexterity for 5-fingered robot hands. So RLWRLD just showcased their new foundation model called RLDX1, and it's running on WIRobotics ALLEX humanoid to unpackage and repackage a computer mouse. And it's managing this entire sequence you see here completely autonomously. And in terms of benchmarks, it actually clocked an 86% in real-world success rate, and this beats rivals like NVIDIA's Groot and Physical Intelligence's Pi 0.5, which hover at about 40% success. And look at how it grips the box here. It relies on real-time torque and weight data to apply the perfect pressure so it doesn't crush it. See how it closes that box there? And there's virtually zero lag between its decisions because the model uses a unique multi-stream action transformer. And this is actually based on the exact same architecture that powers the famous Flux image generator, but it's completely rewired for robotic control. And it pops that right into the box there, working with the second robot. And in order to teach these robots how to do this, they didn't use expensive tracking gloves, but instead they just recorded standard videos of bare human hands, and then they reconstructed it in 3D using Gaussian splatting. And then they spun it out into simulation to generate over 200 synthetic training demos every single hour. And you see the robot here doing this task one more time. And the craziest part here is that unlike Tesla's Optimus or Figure 03, which are completely proprietary, RLWRLD just released these model weights completely open source on GitHub and Hugging Face. So they're effectively trying to build a universal free Linux operating system for the entire automated global workforce of humanoid robots that can work together with each other. Here you see, although these robots are moving at a much slower pace, this is fully autonomous, and over time, obviously they will speed up to be able to eventually outperform humans. And you see this handoff to the second robot here to package inside of the box. So comment down below how much faster you think this needs to be ready for commercial prime time, and how much do you think this would be worth to a business? And finally, in an oncoming generative AI breakthrough, Google is testing an unannounced video generation engine that is being called Gemini Omni ahead of Google's I/O 2026. And according to user interface leaks, this new model appeared inside of Gemini's video creation tab alongside Toucan, which is the internal identifier for Google's current VO 3.1 system. And it read, "Start with an idea or try a template powered by Omni." And according to this video that was released, it indicates notable capabilities in text-in-frame rendering and contact physics. But operational efficiency remains a barrier here because early user logs also reveal that generating just 2 short clips consumed roughly 86% of a subscriber's daily AI Pro computing quota. So comment down below whether or not you think this is better than Seedance 2.0. Like and subscribe, and check out this video for more in the latest in AI and robotics news.